Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So water to orange is 3-2. Ooh. We've got water here and we've got orange squash here. And we're told that we've got 80 centilitres of orange. So we've got 80 here. And we're asked to find the amount of water required. So what we do is we figure out how to get from 2 to 80. Well, we're going to times by 40. If I times that side of the ratio by 40, I've got to times the left-hand side by 40 as well. 3 times 40 is 120. So I'm going to need 120 centilitres of water. So there's a formula for percentage increase or percentage change. And it is the change over the original amount times 100%. So to find out the change here, we're going to do the difference between 1421 and 1100. So we're going to do 1421 take away 1100, which is 321. Divide that by the original amount. So the original amount was the 1100, and then times by 100%. And that's going to be 29.18%. With these questions, we've just got to go around and fill in what we can, and there's going to be some numbers like this one here we can't fill in yet, so we're going to have to be strategic in the order we do it. I'm going to first of all look here, and notice that the total of girls and boys is 29, the total of the boys is 18. So take away the 18 from 29 and we get 11. Next one I'm going to fill out is this one. Notice that the total for the green is 15, total for the boys who's picked green is 12, and therefore for the girls it's going to be 3. Then looking around, what's the next thing that we can fill out? We can fill out this one because the total for the boys is 18, green is 12, blue is 1, therefore we've got 5 left over. Then we can fill out this one, 2 plus 5 is 7. Then we can fill out this one, so 2 plus 3 is 5, then plus another 6 would be 11, and then 6 plus 1 is 7. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed distance time triangle. So speed equals distance over time. and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it will be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us, what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in 2s, so this will be 28, so the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by -3, because they're minusing 3 each time. So we know that the number before the n is going to be -3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3, and we would find it to be 20. So whatever numbers our 0th term, because 17 is our first term, is going to be what we add to the -3n. So it's going to be add 20. So our answer is -3n plus 20. To find average speed, we do the total distance and we divide it by the total time. Now in this question we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers, because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got a hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270, because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434. blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So A plus B minus C will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9, and so that will be minus 18. So our column vector will become 18 minus 18. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. An exponential growth would show an increase from left to right. But the graph we've got in front of us, or the sketch, is showing it decreasing. So it's going to be a decay. Okay, so first thing I'm going to do is just a quick sketch of this diagram. So we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. So we're given the equation of the line, which is y equals ka to the power of x, and we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate, and we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. So if we have x equals the 0.098, 9898 blah blah blah, we actually want the repeating pattern to be next to the decimal point. So we're actually more interested in 10x, and so that'd be 0.9898 blah 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 blah. And we want the repeating pattern to also be in front of the decimal point, so just the digits that repeat. So if we did 100x, it would just be the 9, so we need to do 1000x. And that will give us 98.9898 blah 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 blah. And we can see here, if we subtract these now, so we subtract the left and the right hand side. On the left hand side, 1000x take away 10x would be 990x. And on the right hand side, we're actually just going to get rid of the repeating pattern, so that would just equal 98. And then we want to solve, so we're going to divide both sides by 990. And divide just means over, so we can just write it as a fraction. Now they are both even, so chances are, well, they will definitely divide by 2. And so we divide top and bottom by 2 and we get 49 over 495. Here we've got a cubic graph and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this. So we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at -7 the first time going down, and then it touches it at -7 going up. So there's technically 2 roots there. Sort of one root, but it counts twice because it's going down on one root and then up on the other root. So with these, what we need to do is we need to make sure that at x equals 6 and x equals 7, -7, that this equation, the whole thing equals 0. So if we imagine A, what does A have to be to make this whole thing equal 0 when we look at this, the fact that a root is at 6? Well, if we put A at -6, we get x minus 6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if A is -6, let's have a look at B. So what does B have to be? Well, if that's -7, if we put B as +7, then when we substitute in this -7 here into the x, we get -7 plus 7, which is 0. So if B is -7, then the whole, +7, then the whole thing will be 0 at x equals -7. And for the C, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is A, which is B, which is C? Actually, it doesn't matter. We could put A at -6 and A at 7 and B at -6 and C at 7. As long as one of these is -6, 1 and 2 of these are 7, you'll always get the right answer. So we're asked to first of all complete the square. So that's what we're going to do. And to complete the square, we've got to remove the minus from the x squared because we've got to have x squared. So we're just going to factorise out the -1 effectively. We have minus x squared, and this has to be minus 10x. And then we're just going to leave the +7 on its own at the end there. And the reason this is a minus 10x is a -1 times minus 10x is 10x. Okay, so we're going to leave that, and we're going to just focus on the x squared minus 10x. So the way we complete the square is you do a bracket, and you have x, and then you halve what the coefficient of the x is, so that'd be -5, and then square it. Now if you expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25, right, we need to get rid of that 25. And so I'm going to now expand the bracket with the minus on. So we've got minus x minus 5 squared plus 25 plus 7. And then we're just going to add the 25 and the 7, and you should get 32. Now, if I'm to draw the graph of y equals minus x squared, it's just a graph that looks like this, but more importantly that their maximum point on this graph is at 0, 0. And if we remember our graphic transformations say that if we have a minus 5 on the inside of our function, and so comparing this function, say this is f of x, part of this equation here involves a minus 5 inside the function. That minus 5 moves the graph to the right 5. Okay, so we're going to move it to the right 5. Similarly, if you have a function and you've got a plus 32 on the outside of it, which we have here, it's going to move it up 32. So instead of our maximum point being at 0, 0, it's moving to the right 5, so the x coordinate would be 5, and up 32, so the y coordinate would be 32. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.